So we're creating two vegetarian lines here. You like that one, Mikey? Some of my best work. Just going to give us a line. I'm going to make my first line. Here's the wonderful thing about rulers. If I want to draw my second line, draw it on the back side of the ruler. Are those lines parallel?
Yes.
How do you know? They'll never meet? Ever? How do you know? If I extend that on forever, how do you know they'll never meet? Because they're straight. So straight lines can't meet. Those lines are straight, they meet.
The same grade.
Very good. What can you say about their gradient? It's the same. Now, no one in the room will have a gradient that is exactly the same as mine. So when I talk about the gradients are the same, what am I saying? The gradients between the two rise-over-runs, or the two lines, must be the same. Cool? So if you've got that, well done, your gradients are the same, then you've got parallel lines. Does this make sense when we think about a simultaneous equation? So I'll give you a number for this. Let's just say this function here, the first one is negative 2x minus 1, and the second one is, well, what must be the gradient? So the negative 2x, and we'll make that minus 3. Happy with that?
Yes.
So if I substitute that in, I'm going to get negative 2x minus 3 equals negative 2x minus 1. What's my first step? Get rid of my x's. Okay, so I'm going to add 2x to this side. What's going to happen?
Both cancel.
Oh, they're going to cancel, and they're going to cancel. Does that make sense?
Yeah.
Because I'm trying to find a point where these two lines meet. Negative 1 equals negative 3. That doesn't make any sense. So what that is telling us is these lines will never meet. Cool? So if we think about our simultaneous equations, that's a proof about parallel lines never meeting with the same gradient. Because if we try and solve them simultaneously, we're not going to get a solution. So that's the first part of that. Who feels pretty comfortable with their understanding of parallel lines and they're pretty happy with that? Cool. If my first line had a gradient of 15, what must my second line have a gradient? 15. It doesn't matter what my C value is, it just has to be different to my first one. Cool? Perpendicular lines. So I want you all now to draw a line that is perpendicular to one of your lines. What does perpendicular mean? Well, it means at right angles. So if I put a right angle between my line, is that line perpendicular?
Yes.
What about this line?
Yes.
Is that line perpendicular? What can you tell me the gradients of those lines?
It's just the same.
They're the same as each other, very good. What can you tell me about which line have I been perpendicular with? Who thinks I've been perpendicular with the top line? Ah, very good, I've been perpendicular with both lines. So what is that telling us? I didn't specify which one. I reckon I could walk around the room and every person's got a line that's perpendicular to both of those lines. Correct? Is there a relationship between being perpendicular and the gradient? Is there a relationship or not? There is, isn't there? How do we know that? How do we know that? I said, is there a relationship between a perpendicular line and the gradient of the original line?
Yes.
There is, correct? Because both these have got the same gradient. Both my red lines have got the same gradient. And both my perpendicular lines have got the same gradient, correct? If my original line, so my red line, was really steep, what would happen to my perpendicular line?
It'd be steep, but that's
So if my original line's like this, what's my perpendicular line going to look like? It's going to be pretty flat, isn't it, correct? And what about as I get flatter and flatter, what happens to my perpendicular line? Steeper. What do you notice about if my yellow one is my regular line and the white rule is my perpendicular line, what do you notice about the gradients? Is this one negative or positive? What about this one? Okay, well let's swap that around now. What happened? They swap. So I want you to fill out these. What can you say about the gradient of my perpendicular line? The steeper my original line gets, the something my perpendicular line gets. I want you to fill that out from what you just saw. Have a think. When my line has a positive or negative, you pick whichever one you've got. So I've left both options open. So if you've got a positive gradient, what happened to your perpendicular line? If your regular line had a negative gradient, what happened to your perpendicular line? So circle whichever one of these is relevant for you.
Is that two words?
Yeah, you can use two if you want. Or you just use one word and that was fine. I had a different word in my mind, but that's fine. So Mikey, the steeper my line got, the?
More horizontal.
Yep, or the less steep will work for me. The less steep, the perpendicular line is correct. When my line has a positive gradient, the perpendicular line has a negative. When my line has a negative gradient, the perpendicular line has a positive. So what does that tell me about the equations for these lines? Let's start with the parallel line. The gradient of the parallel line equals the same as the original function, so it equals the m. I could put of the original or just m if you'd like. Happy with that? Does that make sense or not? So do we really need an equation for that? Not really. We know that parallel lines have got the same gradient, so I wouldn't even worry about that equation. But we do need an equation for our perpendicular line. So I want you to think and write down what you think the perpendicular line equation will be. This is going to be tricky, but I want you to have a think. I want you to have a think. The only signs that you can use are 1, a negative sign, and m. They're the only signs you will need. And a line maybe. I don't know. Have a think. Give you 10 seconds. Anyone who gets it gets a chocolate. Give me the equation for the perpendicular line. You can use 1, negative, m, and a line.
Wouldn't it just be negative m?
Anyone think they've got it?
What is m parallel?
M parallel, m perpendicular. Gradient of the perpendicular, gradient of the parallel. No one's got it. Oh well, I'll just be having my chocolates all by myself. So, explain why, just before we go, how does that work? What's the negative dealing with? If my original gradient's a negative, I need to get a positive. So that's how I get the negative value at the front. If my original gradient's positive, I need a negative value, correct? The steeper, so the bigger my regular gradient is, the smaller my perpendicular must get. So we've got negative 1 on m. I'd definitely make sure you get that equation down because I may not be here for the rest of the week. I might not be here for the rest of the week. You're away Wednesday anyway.